We're going to start off by talking about the linear function. And with the linear function, we want to look at slope-intercept form, which is y equals mx plus b, where m, my coefficient from the x, is going to be my slope. So look for that number there. And b is my y-intercept. So looking at my example here, y equals 2x plus 3. What is the slope of this line?
2x plus 3.
No, what is the slope?
2.
Specifically, very good. The slope is 2, coefficient in front of my variable. And if the slope is 2, what is my y-intercept?
3.
Now, be careful. If you put 3 in my math lab, it's going to say wrong. Because y-intercept is a...
Put positive 3.
No, y-intercept is a coordinate. So y-intercept is 0, 3. Make sure you make that adjustment. Do not put 3. Y-intercept is 0, 3. That is my
So we
y-intercept.
just put 0 all the time? It's just a number by itself?
Pretty much. So y-intercept is 0 slash b, or 0 comma b. That is what the y-intercept should be.
Man, this math is
Now, there's another type of form with linear functions, and that is standard form. Notice I have my x and y variable on the same side of the equal sign. So ax plus by equals c. If I want to go from standard form to slope-intercept form, what do I need to solve this form in terms of what? Which variable? If I want to go from here to here, I need to solve for y. I need to make it y equals. So I need to move everything over. So I have 3x minus 2y equals negative 16. I can't, in this form, figure out what the slope and the y-intercept is, so I need to change it to slope-intercept form. So what should I move over to make this a y equals? What would you move over?
16? Negative 16? No, wait, no.
No, the x.
Yeah, 3.
Yeah, okay, let's get y by itself first. So let me move this 3x over. So subtract 3x on both sides. That gives me negative 2y equals negative 3x minus 16. And after that, not quite there yet because it needs to look like a y equals,
Plus 16.
not plus 16.
Oh, no. Is it
So you want it to look like this.
minus 2?
So there's something else attached to it. Yes,
Plus 2,
negative
plus
2,
2.
not plus 2. This is
Divided
negative
by
2
8.
times y. So what's up some multiplying by 2?
Oh.
Divided by negative 2. Like so. See how this is good multiplication? You have to do the opposite operation. So divide it. That's going to give me my y equals. What is negative 3 divided by negative 2?
Negative 1? Oh, wait.
That's a positive 3 over 2.
Double.
X. And what is negative 16 divided by negative 2? I say plus 16 divided by 2 is?
8.
8. So I get y equals 3 over 2x plus 8. And somebody tell me, what is my slope? In terms of slope, we call it m. So m equals what?
Oh, 8.
My slope?
Oh, 3 over 2.
3 over 2. And what is the y-intercept?
Oh, 8.
Not 8. My math lab accounted wrong.
So it said, oh, 8.
0, 8.
Oh, that's what you mean. Oh, wait. So 0, 8, yes. Coordinates, 0, 8. Let me have you work number 2 while I finish up on attendance. Put that in the slope-intercept form and find the slope and the y-intercept.
13.
Yep, the 13x. So let me subtract 13x on both sides. I get negative 11y equals negative 13x minus 12. And then one more.
Divide by
11.
Divide by negative 11. Notice how I'm dividing by everything. So that's y equals positive 13 over 11x and a positive 12 over 11. So what is my slope?
13 over 11x.
What is my y-intercept?
12. Wait, oh, 12, 11, right?
0, 12 over 11. Yes, it is a coordinate. So 0, comma, 12 over 11. Again, I'm going to harp on this because my math lab will 100% count that wrong. You just put 12 over 11.
Oh, 12, 11.
Now let's talk about slope some more. With slope, we define slope as a rise over the run. It is the change in my y value between this coordinate and this coordinate over the change in my x value, going from here to here. So as I look at my y values here with these 2 points, I have -1 and I'm going to 3. So how many units did that change from -1 to 3?
4.
I went 1, 2, 3, 4. Yep. I changed by a unit of 4. Now, was that a positive increase or a negative increase?
Positive.
I went up, so that's a +4. So my rise here is a +4 over, and my run, I'm looking at my x values. So I went from -2 to 4. What is my change of units there?
6.
1, 2, 3, 4, 5, 6. And is that was that a positive or a negative?
Positive.
And I went in a positive direction. I went this way. So that is also a +6. So my slope is +4 over +6, which simplifies to
4 or 6.
no.
Wait, +4 or +6.
What's 4, 6 simplified to?
2.
2 over
3.
3. Very good. 2/3. So I have a slope of 2 over 3. And I can see that if I have this point here and I go up 2, 1, 2, and over 3, I land on another point on my line, right there. So it does in fact have a slope of 2/3. Notice this is a positive slope. It is going to the right. Notice how it's leaning to the right.
The positive man.
Both positive man, you have some kind of special trick? I
Yeah.
don't know about. I heard some people say it's like the check mark.
Or the slope man, where you go like that. And then
Okay. So let's see. Daniel says the slope man. Sure. I see that. What's that? Okay, so some have seen this is a negative slope, so N for negative. And if you look inside of your capital letter N, you have the negative slope. Pretty cool, huh? It matches up with this one. Now, why is it a negative slope? Because, well, if I'm going from here to here, I'm going down, so that is a negative direction, and then over 1, which is a positive direction. Or I can think of it going this way, left, a negative direction, and then up, a positive direction.
yeah, positive plus negative.
Notice how only one of these is negative. If they're both negative, well, what happens? So if I start here, and I'm going down, negative, and over to the left, negative, notice how it makes a positive slope.
Mhm.
Why?
Because you could, it's just, isn't it just invert? Or
Pass each other out.
What's that?
Like
Pass
invert?
each other out.
Think of, this is a fraction, 2/3, but you also think of it as 2 divided by 3. What is a negative number divided by a negative number? A positive number. So that's why when you go negative,
Oh,
negative.
two
But,
negatives, yeah.
yeah, 2 negative. Well, you could also look at it this way. I'm going up, positive, and over to the right, positive.
Yeah.
So it kind of makes a box. So you go negative, negative, which is positive, or positive, positive, which is positive. But with negative slope, you're only going to have one negative. I just want to bring it up. So yeah, we've got some tricks here. Positive, negative man, or just no negative slope goes like that with the capital N. Other types of slopes, we have the zero slope and the undefined slope. I like to think of skiing. If you're skiing on a zero slope, where are you going?
Nowhere.
Nowhere. So we can also call this the no slope. You're not going anywhere if you're skiing on that. So think of skiing on a horizontal surface, you're going 0. You're going nowhere. If you're skiing on a cliff and you fall off, what happens?
You either go down.
Undefined. So don't even think about it. You don't even think about this kind of slope. So that is an undefined slope, a vertical slope. So no slope is horizontal, undefined slope is vertical.
I think that's what that was. It was like this. Now that I think of it, there was more to it.
There's more to it.
Yeah, and it goes like that.
Ah. But how did it help you a no or?
There was more stuff, but if we keep going,
Okay.
I might be able to remember.
So as we look here in the next example, I'm only given the graph. I want to find the slope and the y-intercept. I can tell what my y-intercept is, where it's crossing the y-axis. What is the coordinate of that point?
1, 2, 3, 4.
So it is what? 0, not 4. but negative 4, right? 0, negative 4 is my y-intercept. What is my slope? Remember how to find the slope? Rise over run, so how far are you going? From here to here, 1, 2, 3, so a plus 3. And then I go over in a positive direction, 1. So it's 3 over 1, or just 3. Now that is enough information to tell me what the equation is, written in y-intercept form. So y equals
3.
Plus, minus 4.
3x minus 4. Very good. Y equals 3x minus 4.
I think this is what it was.
Ah, with a U, okay. Interesting.
Whoops.
Now, what if you were given these types of slopes and you're asked to find the equation? Looking at number 1, right here. What is the equation of this line? Well, first off, tell me what is the slope?
Different slope.
It's not the no slope, it's the
Undefined.
undefined. It's not the 0 slope. Remember, think 0. You're going nowhere. You are going somewhere if you try to ski on this slope.
Going straight down or
Yeah, you're going straight down. So that is a undefined slope. Does it have a y-intercept?
no.
Okay, it doesn't have a y-intercept. It doesn't have a defined slope. So there's no way I could put it into y equals mx plus b.
No solution.
It's not a no solution. There is an equation. Maybe we can look at the coordinates and they can help us out. If y is 0, what is x equal to?
Negative 2.
Negative 2. If y is 1, what is x equal to?
1.
No.
Negative 1. I mean,
No.
negative 2.
Negative 2. So 0 and 1 is negative 2. If y is 3, what is x equal to?
Negative 2.
Negative 2. If y is negative 4, what is x equal to?
Negative 2. So it's
So x is always equal to
negative 2.
negative 2.
That is.
And there's your equation. X equals negative 2. So an undefined doesn't fit into your y equals mx plus b, but it does fit into your x equals whatever that value is. In this case, negative 2. Just notice, no matter what y is, I'm always going to equal
Negative 2.
negative 2. We can use that same logic here. Can somebody tell me what is the equation for this line?
0.
Y equals
Well, what's the slope?
0.
Slope is 0. What's the y-intercept?
Yeah, 3.
Not 3.
Oh, 3.
0, 3. I can in fact make an equation from this. So y equals 0x plus 3, right?
Yeah.
And 0 times the number just goes away. So y equals
3.
3. And again, I can see that no matter what x equals, what does y equal?
The same on
The
the
same,
opposite.
it's the same every time, right? 3. X equals 2. Well, y equals 3. X equals 4. 3. 5. 3. Infinity. 3. Y is always going to equal 3. Can somebody tell me the equation on number 3?
It is m equals 0 and 0, 3. Y equals 0 x plus.
Anybody have the equation? Anthony? No. You sure?
Yeah, you do.
I think you do.
It's
What does y always equal here in this line?
0.
Well, no. Here's the line here.
Y?
This is my y, my x-axis. So y is down here. What is this point right here? Maybe we'll start there.
Infinity?
Let's say, well, I mean, the arrow's going to continue. So we'll call it on this point. So this is 1, 2, 3, 4, negative 5. So 0, negative 5. You told me it has a slope of what? This is a what? 0. So you're skiing, you're going nowhere. If I were to plug into y equals mx plus b, so 0x
Minus 5.
minus 5, that goes away. Y equals
Negative 5.
negative 5. Again, what is y always going to be equal to? Negative 5. No matter what, it's staying right here on y equals negative 5. So watch out for these types of graphs. Make sure you think through. Don't just rush it. With slope, we can also plot two lines on the same graph, and with that comes parallel lines and perpendicular lines. The notation I'm going to use for parallel lines is going to look like that. So if you see those two lines like that, think parallel. I have two parallel lines here. Y equals 3 over 4x plus 1, and y equals 3 over 4x minus 3. What can you tell me about parallel lines?
They never touch.
They never touch. What can you tell me about the slope of parallel lines?
It's always the same.
They're always the same. So slope 1 equals slope 2, then those lines are parallel. If they have the same slope, they're parallel. Now perpendicular, if you see me draw this, that means perpendicular. I have two lines that are perpendicular. What does it mean to be perpendicular?
To create a right angle.
Cross?
To cross at a
Right angle.
right angle. So let's look at the orange line. I have y equals 3x minus 1. What is the slope of that line?
3x. I mean 3.
3. M equals 3. My blue line, I have y equals negative 1/3 x minus 2. What's its slope?
Negative 1/3.
Negative 1/3. These are perpendicular. So tell me, how do you go from one slope to another to verify they're perpendicular?
Rise over run.
So, okay, we can look at rise over run. So I have 3 over 1, and its perpendicular is 1 over 3. What happened?
Flip.
It flipped. Also notice it's positive. What happened to this slope?
It's negative.
It's negative. So we have to take the fraction, flip it, and change the sign. So where I have slope m1 is perpendicular, perpendicular is 1 over m2, change the sign.
What? Okay.
Because let's look. Let me demonstrate. If I were to graph 2x, there's my line. If I make that a negative 2x, do these cross at a right angle?
No.
No. If I were to make this flip it and I get 1/2, are these a right angle? No. So it's not enough just to flip the fraction.
Would it be 2-1?
What else do we do?
Add a
We
negative.
flipped it and we flipped the sign. So if I had a negative, now they form a right angle here. So you have to flip the fraction. So if I have 5 over 4, what is 5 over 4? What's the reciprocal?
Negative 4 over 5.
Yeah, negative 4 over 5. So it's opposite reciprocal. So you got to change the sign and change
Change sign, flip number.
and flip the fraction. Let's do some more practice here. Number 1. What is going to be parallel to a slope of 3?
3.
3.
Yeah.
What is perpendicular to a slope of 3?
1/3. Negative.
Very good. Negative 1/3. Okay. Let's look at slope negative 3/2. What is parallel to negative 3/2?
Positive 2/3.
No,
Negative
parallel.
3/2.
Oh, parallel.
Negative 3/2. And now you spoil the surprise for perpendicular, which is
Positive 2/3.
positive 2/3.
Impossible.
Parallel to negative 1
Negative 1.
is negative 1. And be careful, perpendicular to negative 1 is
Negative 1.
Positive 1.
just a positive 1, right?
Ha.
1 over 1 is 1 over 1.
It's 1.
And I got to flip it, the sign. So negative
1
and
over
positive.
1 is 1 over 1 is 1.
And last but not least, what's parallel to negative 1/4?
I don't know. What's that?
Negative 1 4.
Negative 1/4. And what's perpendicular?
4/1.
4 over 1, or just 4. Here's a brain teaser for you.
No more.
X equals 3. What is perpendicular to x equals 3?
Y equals 3.
Ah, somebody smart. Y equals 3.
Or it could be Y
Because
equals
it's already making a right angle.
maybe A and Y.
Or it could be any y, sorry. Think of it as this. X equals 3. What type of slope is this?
Is it not
I mean, they're fine.
parallel? Oh, wait, no. Oh.
Undefined. So it's
Yeah.
going up and down. What's perpendicular to a horizontal line? Or sorry, what's perpendicular to a vertical line?
0.
Horizontal.
A horizontal line. That's what I was trying to get at. Horizontal.
Yeah, that's
And the only way to get a horizontal is y equals
They're already
3.
making right angles.
So we need to look at that. So x equals 2. If you were to flip that and give me the opposite, x equals negative 1 over 2, well, they are what?
Parallel.
Parallel. Because these are both undefined, right? X equals. So you need to give me a y equal that is going to be perpendicular. And like Jaden said, it could be actually any y equal. 3, 6, 5. All of these are no slopes. Negative 5. It could be any y equal. So that's something to watch out for perpendicular. If you have an undefined slope, it's perpendicular to a no slope, and vice versa. So number 9, y equals 7x plus 2 and y equals 7x minus 1. Are these parallel, perpendicular, or neither?
Parallel to the first one.
Yep, because they both have a slope of 7. These are parallel. Number 10, 4/5 x minus 8 and y equals negative 5/4 x plus 3. Are these parallel, perpendicular, or neither?
Perpendicular.
These are perpendicular. Now to wrap up everything we've done today, let me give you a minute to solve these two problems here. Slope-intercept form, so I can just read off the slope. I see with 13, I have a slope of negative 1/5 here. But this is in standard form, right? I need to change that into slope-intercept form. So let me move things over. So subtract 5x on both sides. That's going to give me a negative y equals negative 5x plus 4. And now I need to account for this negative, so let me just multiply this whole thing by a negative 1, or you can divide by the whole thing by a negative 1. That's y equals 5x minus 4, which gives me a slope of 5. So now that I have the slope from both of these,
Okay. So when we have
are they parallel, perpendicular, or neither?
perpendicular.
These are perpendicular. Number 14, they're both in standard form, so I need to convert both of them. So I'm moving the 3x here. Gives me a negative y equals negative 3x plus 2. And again, let me multiply the whole thing by a negative 1.
3.
Y equals 3x minus 2, which gives me a slope of 3. So there's that one. And then here, let me subtract 12x on both sides. I get negative 4y equals negative 12x plus 4. And now divide by a negative 4. I get y equals what?
4.
12 divided by 4 is 3x minus 1. Hopefully. 3x minus 1 gives me a slope of
Yeah, 3.
3.
Parallel.
And these are parallel.
Okay.
Very good.
That was probably like the confusing part for me.
Notice you can't grab these in your graphic calculator in standard form. You have to put them in slope-intercept form
Alright.
because your calculator is expecting a y equals.